Good morning, Chem 1 students. Well, I guess if you're watching this video at home, it could be good evening. But really, what does it matter? Greetings, this is Mr. Braun. Today, we're going to discuss molar mass. Now, we have one main objective for you after you watch this video. And that one main objective is you need to be able to calculate the molar mass of a substance. All right, let's first discuss the molar mass. What is molar mass? Well, ladies and gents, the mass of 1 mole of a pure substance is the molar mass. So, when we talk about the molar mass, it is how much a pure substance weighs. Okay? The molar mass is usually written with the unit of grams per mole. All right? Grams per mole. So, if I look, lithium. Let's find lithium on the periodic table. The mass of 1 pure substance of lithium, the mass of 1 atom of lithium is 6.941 grams per mole. What does that number represent? Yes, ladies and gentlemen, once again, that is the atomic weight. The red number in the box, at the top of the box on our periodic table. Mercury. Find mercury. Element number 80. Hg. Mercury has a molar mass of 200.59 grams per mole. Now, let's just jump right in it, folks. Let's just jump right in it. What is the molar mass of sodium chloride? This is why I love these things, folks, because right now here, geesh, sodium chloride, okay? I need to write the formula for that guy. Wow, we got to go back to our nomenclature that we did last unit. Sodium chloride's an easy one. Sodium chloride's an easy one because we know sodium, Na+1, chlorine, Cl -1. So sodium chloride, ladies and gentlemen, will be NaCl. Now, in answering my question, how am I going to find the molar mass of sodium chloride? First of all, I look and I say sodium, element number 11 on my periodic table. It has an atomic weight of 22.9898. How many sodiums do I have here? Oh, there's nothing behind it, so I have 1 sodium. There we go. So my mass due to sodium is 22.99. Now for this purpose, folks, I've rounded it to 2 places past the decimal point. If I were you and I'm doing this on WebAssign, I would take it all the way out. I would use the entire number. Look at chlorine here. Look at chlorine. I have 1 chlorine. Each chlorine has a mass of 35.45 grams. So I would set this problem up exactly like this. Chlorine 1 times 35.45. All right. Now, how do I determine the molar mass? Excuse me. All I do is simply add them together. 22.99 plus 35.45. That's going to give me a value of 58.44 grams per mole. Now, ladies and gentlemen, okay, let's go back. Let's think a little bit here. Let's say that we're not the best people writing formulas given a name. Let's say that when we started out naming or writing the formula for this sodium chloride name. Let's say, hey, we did it wrong. And instead of having NaCl, like I have up here, let's say we had NaCl2. Now, all of a sudden, you would put a 2 here, so this number would be doubled. Would we then have the same molar mass? No, we would not. So, ladies and gentlemen, this is wrong. All right? This is wrong. So, if you cannot name if you cannot write the compound or write the formula for the compound, we are going to have a mighty tough time adding up the molar mass. That's why it's so important to be able to name or write the formulas for the name. That's why I said, if you can't do nomenclature, we're going to study for some time now. So, sodium chloride, molar mass, 58.44 grams. What is the molar mass of dinitrogen pentoxide? Dinitrogen pentoxide. But once again, we have to be able to write the formula. I see prefixes. So I'm dealing with a binary molecular compound. Dinitrogen, there's 2 nitrogens. Pentoxide, there's 5 oxygens. So, N2O5 is my formula for dinitrogen pentoxide. So how am I going to find the molar mass of that? Well, I can see that I have 2 nitrogens. How much does each nitrogen weigh? Well, as on my periodic table it's looking at, nitrogen says 14.0067 grams. So, for nitrogen, 2 times 14.01, rounded to 2 decimal places. So 14.01 times 2, my mass due to the nitrogen is going to be 28. How many oxygens do I have? I have 5 of them. Each oxygen weighs 15.9994. When I round that to 2 places past the decimal, that's going to give me 16. So 5 times 16 is 80. When I add 28.02 with 80, I get the value of 108.02 grams per mole. Therefore, ladies and gentlemen, the molar mass of dinitrogen pentoxide is 108.02 grams per mole. Doesn't seem too tough, does it? Once again, though, if I get this wrong, if I can't write the formula for the name, I can't do it. Dichromic acid. Uh-oh, I see the word acid here. Uh-oh, I see 1 or 3. I'm back on those acid rules again. I see 1 or 3. What acid rule is this? Ooh, there's no hydro, so it's got to be acid rule number 3. So I am looking for the anion dichromate. Well, ladies and gentlemen, I grab my periodic table and I look for dichromate. And I find that to be Cr2O7 2 minus. Ladies and gentlemen, since I know my acid rules and I know how to name acids, I can see that that's 2 minus. So what I'm going to have is H2 Cr2O7. Now, when I go to find the molar mass, once again, just the masses off the periodic table. Hydrogen is 1.00794. When I round that to two places, it's 1.01. I take that times 2 because I have 2 hydrogens. It gives me a total of 2.02. Chromium element number 24 on my periodic table, 51.9961. If I'm rounding that to two places, it's going to be 52.00. How many chromiums do I have? Oops, there's 2 of those babies. So my mass due to the chromium is 104. Finally, oxygen, 16.00 when I round it to two places. 16.00 times 7, excuse me, gives me 112. When I do my math, I add all these together. Ladies and gentlemen, the molar mass of dichromic acid is 218.02 grams per mole. Finally, we got our old buddy here, aluminum sulfate. All right, our old buddy here, aluminum sulfate. Now, I threw this guy on here because, gosh darn it, we got parentheses here. We've got parentheses because aluminum's a 3+, sulfate's a 2-. So I'm going to have my molecular form, excuse me, it's not a molecular formula, okay? I'm going to have my formula unit, my formula for aluminum sulfate, Al2, parentheses SO4, 3. So I have 3 of these sulfate polyatomic ions. When I go to calculate the mass, I find aluminum on the periodic table, element number 13, 26.98. Times 2 of those babies, it's going to give me 53.96. Now here's the rub. Sulfur. I have 1 sulfur, each polyatomic, but I have 3 of them. So my sulfur, which is 32.065, when I round it to two places after the decimal, oh my goodness, I'm dealing with the even rule. So it's 32.06 times 3 is going to give me 96.18. If you have forgot about the even rule, you need to go back and review it because there's a couple of times on the periodic table that we will run into it. Oxygen now. I know it's 16.0. Each polyatomic has 4. We have 3. What's 4 times 3, ladies and gentlemen? My math tells me that's 12. 12 times 16 is 192. So when I add all of these babies up, 53.96, 96.18, 192.00, I come up with a molar mass for aluminum sulfate of 342.14 grams per mole. Ladies and gentlemen, what does that tell me? That tells me if I have 1 mole of aluminum sulfate, how much is it going to weigh? 342.14 grams. That is the molar mass of a substance. This is Mr. Braun. Chem 1. Let's investigate.